we're gonna have a panel discussion. I wanna invite to the stage our co-founder of Zof AI and CEO of Zof AI, Kevin. Let's give him a quick round of applause. Kevin will moderate the panel, and he will invite the panelists as well. There we go, Kevin, all yours.
How's everybody doing?
Good.
Great. America, get up here. Clap for it. Next up is Gwanda Kramer. Mr. Kramer, actually, personal story. Mr. Kramer actually and I met at one of his talks at MIT back in 2009. It's a long time ago. I was a student back then, but the kind of innovative technology they were building back then was so futuristic. I could not imagine that it was present technology at that time. Mr. Kramer, please get up here. All right, first question. In your experience, how have you seen organizations evolve from traditional QA to a more intelligent, proactive approach to quality? What's the biggest mindset shift required for engineering teams to move from testing after the fact to predicting before it happens?
Thank you, and it's great to be here. Don't take this for granted. So, one thing I've seen in the last few years is, and this even started happening before the whole AI race, is I think testing is now being seen as a shared responsibility more and more, right? It's no longer just the QA team's job. Right? And so more engineers are taking on some of the QA responsibilities as well. Not all of them are doing it willingly, right? A lot of times you see it's something that is being pushed more from top down to say, hey, we have to get more proactive in terms of quality assurance.
Change as a company gets bigger, right? Yeah. When you're a very small startup, you have to do QA as the engineering team because you don't have a QA team at all. And I think building tools to help early stage startups actually probably gives you insight into what you can do with the next generation of tools and how AI can support engineers better, because as you grow, you still want to keep those engineers in that QA loop. Even when you have dedicated QA people, if your engineers just throw stuff over the wall to them, that's not a recipe for success. So one of the things I've tried to do, each time I've grown a team is you do a lot of manual testing early on. There's no substitute for the manual testing. And then as time permits, you try to build some tooling around that. You try to get unit tests and integration tests and CI/CD and all the traditional stacks. And one of the things I'd like to ask you is how you think about mapping those traditional layers of the stack to the new AI layers, because I think a lot of us are struggling with that now. But you build the tooling and then you start hiring people who are more specialized on the testing side, but you hope that that tooling stays maybe a glue between the engineering teams and the QA teams.
Yeah, I think one of the most interesting things I've seen a lot of different companies do is they take an expert and they try to train models around all the knowledge that expert has. Like, for example, Midwork, they do automated interviewing, and basically they just brought in a bunch of different managers to tell them specifically who would likely pass an interview and who would likely not pass an interview. So, all right, let's move on to AI and automation. How is AI changing the way we think about testing and quality assurance? Can you share a real example where automation or intelligence tooling significantly improves software reliability and release velocity?
I mean, I definitely feel like as we're using tools that can write code for us, figuring out how to use those tools to do tests as well is really valuable. I spend as much time as I can in code like CLI and Cloud Code these days because it's clearly the future and I don't want to be the old dog that can't learn any new tricks. And I feel like I leveled up in those tools when I started explicitly making sure that the testing was part of the plan that I was iterating on with the code generation tools. Because initially they sort of wrote tests by themselves and I was like, okay, cool. But then, as you get better at understanding the jagged frontier of what these models and what their harnesses can and can't do right now, you sort of focus in on what the important things you have to iterate with the models on. I definitely think testing is one of those things. But when you do it, they're actually very good at writing tests. Like I have a side project now that has 500 unit tests. And I can tell you that I would not have written 500 unit tests by hand. So that feels like progress.
Yeah, that's an interesting one. One thing we're looking at now in my team, because my team is basically a developer ecosystem team, right? We don't build a product, but we build samples and tools and things to support the developer ecosystem. And when you're in a team like that, you don't have all the access to like the QA team, right? Because they're very busy working on like the actual product.
I bet you find a lot of stuff though.
Yeah, oh yeah. So, and it's a pretty lean, especially relative to the scale of work we have to do, it's a pretty lean team. And so we've been, like I'll say, we're one of the teams that really benefited from AI, right? In the sense that we're now able to do more than what able to do in the team.
Intelligence depends heavily on data. What kind of data should teams prioritize collecting and analyzing to make smart quality decisions?
My answer is going to be very biased. One of the teams I manage is the developer support team. And as you can imagine, we have a treasure trove of data in terms of support tickets and the insights that come from that.
And we work with a lot of teams that are trying to go from POC to production. And for a lot of AI agentic use cases, I think we all have seen in 2025, it's really easy to build a POC. It's significantly harder to get to production scale and reliability. What I tell people in the voice agent space is, if you don't already have an evals plan, here's my evals plan for you. You start during the POC phase and build 10 test cases. Build them by hand. Having 10 is better than not having any. And hand build some kind of framework that can run those test cases every time you change the prompt or change the model or try some new chunk of architecture. Just do it by hand. The second phase is, once you're running in a little bit of production, record as much as you can from a legal and compliance perspective. You obviously have to be careful what data you're recording, but if you can record audio calls or transcripts, you then can look at the calls that clearly were failures. You'll always know some things failed. You'll look at those calls that failed, read the transcripts, listen to the recording, and be able to add to those 10 test cases. Because what you're looking for are the places where you didn't know what you didn't know. And you're adding, maybe you get to 100 test cases over a month or so of production, and then you've actually got pretty good test coverage, and you start to feel like you can change your agent code without holding your breath every time you push it into production. And then the third phase is actually a much bigger step. And it's moving towards next generation tooling. There are a few different kinds of next generation tooling. One that I'm really excited about for the long conversational voice AI stuff is simulation-based tooling. So you have a whole lot of stuff going on in production. How can you ever find those corner cases? Well, LLMs are good at categorization. They're also good at structure generation. So generate a large number of synthetic data runs for your voice agents. You will find even more of those corner cases. So that's a sort of step 1, step 2, step 3 that we kind of guide.
To what you were mentioning earlier, how do you balance automation with human elements and of engineering judgment and intuition?
We should continue with the trust but verify mantra. But over time, the models are going to get really good. And we will be able to applicate some responsibilities to them and move on to more complex problems, I think. So that's the way I see it right now.
I think this deterministic versus non-deterministic systems mindset is one of the big things we all have to figure out together. These use cases are so new, these tools are so new, the models are getting better all the time. They're shockingly good at some things, they're surprisingly bad at some things. We're all trying to, I think where we're gonna end up is figuring out what the building blocks are that actually lean into what these systems are good at, and they're really very good at a lot more things, I think, than we have learned how to evaluate. Yeah, if you're gonna try to wrap super deterministic stuff around natural language systems, I think you're swimming against the tide. And that doesn't mean you don't need evals, it doesn't mean you don't need really good tooling to understand what's going on, but maybe we need to drop this idea that what we're trying to do is make these non-deterministic systems behave deterministically. The other thing I was really intrigued by is there are certainly failure cases in the voice agents when they're talking to humans, when they're talking to each other. There are things you're like, oh, I gotta improve that prompt. But sometimes you read a transcript and you start reading through the transcript and you think, this is not gonna work. And then it works. And the reason you think it's not gonna work is because I'm saying me, have 20 years of experience building APIs and you know what you can build an API to do. And APIs are, they're a certain kind of thing and you have to work really hard to design them to be composable and to fit together in the right ways and be broad enough but also be testable, all this stuff. And so you start to see like a LLM do something and you're mapping it onto your experience as a programmer building APIs and you're like, oh yeah, that's not gonna work. And then it works because these are natural language machines. And they don't compose in the same way that APIs do. In many ways they compose better. And there's all sorts of stuff we're gonna figure out how to do with them, like make them write code to do deterministic things when the deterministic thing is the easier thing to do. But there's also all these things we've only just barely started to scratch the surface of that these machines can do that are just brand new qualitative capabilities. And I think we need to lean into that as much as we need to guard against it.
I want you guys to appreciate what we built. Really taking QA to the next level. We didn't respect the status quo at all. We just said that everything that people are doing today that's manual needs to go away. We don't want humans in the loop ever again. And so this is what we came up with. So if you were using the application, you can actually start a test. You go to test, and basically you get to actually just input a requirements document, MD file, user story, or nothing at all. And we'll generate a requirements document based on the endpoint that you give us. So we have built 40 agents to date. We're still building them. I think we can actually schedule a workflow test or just targeting one specific agent, or targeting multiple agents at once. And it can run at night for 2 weeks. We have an endurance agent that can run as long as you want it to run to simulate what it would look like if you're running a high compute service on the platform for an extended period of time. Applications. So I mentioned how we crawl an application and gather scope. This is where we tell you, okay, while we're crawling, we notice some performance gaps, and so we surface that in the application studio. And so application studio, this is where if you don't give us any specification at all, we generate one for you. But the one you give us, we tell you the gaps within that specification. So if you were to give us this,